Hello viewers, welcome to my channel. I am Instructor Allison and I want to sincerely appreciate the returning viewers. Thank you very much. I really love you. And if this is the first time of visiting this channel, please turn on the notification bell, subscribe to my channel, like the video, and then stay subscribed. Alright, so this is a topic under algebra that a lot of students have been having problem with, and I want to assure you, by the time you're done watching this video, you're going to learn a lot of things, because I'm going to take it step by step, break down the process, so that I won't assume you've known mathematics already. I will assume that you've not known anything about mathematics, so that I can be able to follow it step by step. So just stay, keep watching as I'm going to solve all this problem. All right, you can check from question 1 to 6. They look somehow technical, but they are very simple. Question 5 exactly is the question that occur in this 2022 WAEC. This year's WAEC question, change of subject formula. So before the topic is change of subject formula or rearranging formulas. You can see from the question, make the following the subject of the formula. So we're going to start from this simple problem, and then there we go. So let's go. The first question we are having is to make y the subject of the formula in this expression. What does that really mean? It means that you should make y to stand all by itself. That is to say, another term you can say that you should express y in terms of x. So that is what it means. So how do we do that? We have a lot of ways we can approach this problem, but one of the simple ways is to subtract both sides of the equation by x. If I subtract this first expression of maybe this first, the left hand side by x, and also subtract the right hand side by x, it is simple that you can easily say that x minus x, that is 0, it will cancel out. All we left is y equal to, here we're having 7 minus x. And this stands to be the answer. That is very simple. Alternatively, you could just say, since the equation is x plus y equal to 7, and you're asked to make y the subject of the formula, it's just a simple thing that you could easily say, taking this x across, when it crosses it, this has a positive sign by default. When it crosses the equality sign, it changes to negative. That's to say, if I have here to be negative and it crosses the equality sign, it changes to positive. So notice when sign crosses equality, it changes obviously. So at this point, we are having a positive sign. So if this positive x crosses the right hand of the equation, then we have y equal to 7 minus x. You can see that the connection, is just the same. So that is the answer to this particular question. Okay, let's move straight to the number 2. I hope that is clear to you. So let's see how we can make v the subject of the formula, or express v in terms of p and m. That is to say, you want to make v to stand all by itself, stand alone. So that is what it means to making v the subject of the formula. So it is a simple method, but the process is going to be different from this. All right, so let's see what we can do about this problem. We have P equal to mv. This is an expression in physics called, when you're looking for the momentum of a body, momentum is always mass times the velocity of that body or that object. Similarly, this first expression is just a linear equation. So at this point, you want to make this v the subject of the relation. The best way you can approach this is to divide both sides by m. This m is attached to v, and the relation between these two terms is multiplication. That means m multiplies by v gives mv. So in order for you to separate m from v, you need to act in the opposite direction of multiplication. And what is the opposite of multiplication? That is division. Similarly, the opposite of addition is subtraction, and the opposite of multiplication is division. The same way the opposite of x, is it that exponent? Yeah, exponent, or what do we call it? Yeah, is ln. And similarly, the opposite of logarithm, which is log, yeah, we've done that of log. Ln is same thing with log. The opposite of differentiation, which is dy over dx, or the derivative with respect to x, is integral. So you can see how these things work. So if I want to eliminate the differential function, I can use integration to eliminate it. If I want to eliminate any exponential problem, I can use ln or logarithms to eliminate it. And similarly, if I want to eliminate any function that has to do with positive, I can use negative to eliminate it. And if I have multiplication, I can use division, and vice versa. So that's how it works. All right, so quickly, let's finish up with this. The best option is just to divide both sides by the what attached to v, or we can call it the coefficient of v. So at this point, we can cancel out this. What is left is v, and v is equal to p over m. At this point, we've expressed v in terms of p and m, or making v to stand all by itself. So that is it. All right, that's another process of working on these things. Let's see the next problem, which is number 3. We have E equal to mc squared. This is one of the famous equations in physics, which is Einstein's energy mass equation. So in this case, we are requested, or we need to make C the subject of the formula. So how do we rearrange this expression? It's still almost the same process with this. I need to isolate this m. And how do I do that? Is to divide both sides by m, because it is attached to this c squared by multiplication. Are you there? So in this case, I will have to divide both sides by m so that this cancels out, because whatever I do to the right hand side, I will also do same to the left hand side of the equation. So what will be left is c squared equal to E all over n. Notice in this equation, you are to make c and not c squared the subject of the formula. So the next option is to understand what exactly can remove this square. And the only thing that can remove square is square root. Similarly, the only thing that can remove cube root is cube. If I have a fourth root, the only thing that can remove a fourth root, maybe you don't understand what I'm saying. Let's practicalize it. If I have a square root, notice that this square root means a bracket having a square. And then this is supposed to be 2 by default, but in our calculator, you won't see this 2. So when you see 2 here or something of this, by default, this means square root. If I have 3 in a root like this, this means a bracket that has a 3 on it. Right? Or rather 1 over, the inverse, 1 over. Sorry. If I have n, this is called nth root. It means a bracket that has 1 over n. So similarly, if I have 4 here, I can easily fix in 4 here. Anything that comes in here can be inside this bracket. So that's what it literally means. It means at this point that the only thing that can remove this thing is square. Alright? Because if I multiply this by 2 over 1, the inverse of this can easily cancel out with this. Alright. So in that manner, let's see what happened to this. We're going to take the square root of both sides of this equation. Alright, if you don't want to take the square root, you can still multiply both sides by the inverse of these 2. How do I mean? This is what I mean. I can easily multiply these 2 by the inverse of it. And anything I do to the right hand side, I will still do same to the left hand side. So I'll multiply this by the inverse. So this can easily cancel out with this, and what is left is c. C to the power of 1 is still c, equal to, can leave the answer as e over m to the power of 1 over 2, or you can still change this 1 over 2 to be the square root. Half means square root. Remember that, or notice that square root changes to bracket open, then half. on it. All right. So if you get this concept, that's the same thing I'm doing. So you can still change the expression to be the general square root of e over m. All right. So alternatively, you can still address this point in this most simpler way. This is also acceptable by marking scheme. You can still address this by, if we have c squared equal to e over m, you can easily take the square root of c squared equal to the square root of e over m, which this square root can cancel the square, and c will be equal to this same result, which is equivalent to this. Alternatively, you can see how you can be able to address any of these things. All right, if that is well articulated, then let's move straight to the next problem. And the next question is number 4. We have to make s the subject of the relation. And if we have to make s in this expression is a familiar one, and it is one of the equation, Newton's law of motion. No, Newton's equations of motion. The first one has v equal to u plus what's that expression? That is very simple. At, that is u, final velocity, initial velocity, acceleration multiplied by time. The second expression talks about the distance, which is ut plus half at squared. And then the third is v squared equal to u squared plus 2as. So you can see this is the Newton third equations of motion. Equations of motion, not the third law. The third law says to every action there is always equal but opposite reaction. So in this equation of motion, the third equation of motion, we have to make s the subject of the relation. So the first thing you would do is to isolate this u squared, all right, from this right hand side of the equation. And how do I isolate this? It's having a positive sign attached to it. So the best thing you should do is to take this to this, isolate it by taking it to the left hand side. Of course, the sign will change. The default positive sign will change to negative. So at that point, we'll be having v squared minus u squared, and this will be equal to 2as. Alternatively, you can subtract the both side of the equation by minus u squared minus u squared. So this and this will cancel. This will be v squared minus u squared. You can still get this. All right, just keeping things simple. So now we are looking for this s, and this 2 is multiplied by a and is multiplied by s. So I want to remove this 2a so that we can get our s. How do I remove this 2a so that we have this s? Remember, they are all multiplication, and the inverse of multiplication is division. So I'll divide both sides by 2a. If I divide both sides by 2a, this will cancel. So what is left is s. So the s now will be equal to v squared minus u squared all over 2a. And this is the answer to this question 4. We are making progress. We just have 2 questions left. And this is a number 5 question, which came out in WAEC 2022. All right, I think it should be last month or thereabouts. This question came out. So we're going to dissolve it right away. How do we address that problem? The question looks so compounded and so ambiguous or so big, but it's simple. The first step, we have to make Q the subject of the relation, or to make Q to stand all by itself. And in order for we to achieve that, we are going to do something very important. All right, we have a bracket. We have a bracket that has this expression, and it is raised to the power of it has an index of 2 over 3. So the first thing we're going to do, remember or notice that this q is at the denominator of this expression, and we want to isolate, we want to make this the subject of relation, make this to stand alone, and we cannot effect any change on this bracket until or except we remove this 2 over 3. When we remove this, we can be able to assess the quantities in this bracket. So how do we remove this? The simple way to remove this is to take the inverse of this. What do we mean by inverse? The reciprocal of 2 over 3 is 3 over 2, meaning you have to flip it, turn it upside down. So I will multiply this by 3 over 2, that is the inverse, And whatever thing you're doing to the right hand side, you must do same to the left hand side. I'll still multiply this by 3 over 2. And if you do that, you can see that 3 can cancel out with 3 and 2 will cancel out with 2, definitely. So what you'll be having here is p to the power of 3 over 2 equal to, we have arrow k over q minus ms. So now we've freed this expression. You can be able to access everything here. So remember that we are making this q the solving of formula. So the best thing I will do is to pull out this quantity first so that we have this left. We'll pull out this to the left hand side, and this is going with negative sign. So when we isolate this to the left hand side, you can see that this negative sign will change because it's crossing a quality sign to positive. We've established that fact. So at this point, we'll be having p to the power of 3 over 2 plus ms equals 3 arrow k all over q. All right. Having gotten this particular expression, what is the next step? Remember, we are looking for q and not the whole of this. So it is simple. I can easily multiply both sides of the equation. It's easy that I can multiply q, cross multiplication, take this q to this point, and finally divide both sides by this, and I have this over this. But you can still approach it by multiplying both sides of the equation by the inverse of this, or the inverse of the numerator. What do we mean by the inverse of the numerator? The numerator is arrow k, so you're multiplying both sides of the equation by the inverse of arrow k means that you're doing this stuff I just did right now. So at this point, this is multiplication. These two expressions can cancel out with these two expressions. What is left here is 1 over arrow k. I prefer using a parenthesis than using the multiplication. They are the same. So we have p to the power of 3 over 2 plus ms equals 1 over q. After you would have cancelled out this, what is left on the numerator is 1, the denominator is q. Alright, that is simple. This is the last step. The last step now, we're going to flip everything. Notice that 1 over arrow k multiplied by this is the same thing as 1 multiplied by the whole of this, which is the same thing as p to the power of 3 over 2. Remember, 1 multiplied by anything, any quantity, is still that quantity. So 1 multiplied by p to the power of 3 over 2 plus ms will be every of this quantity here. Alright? Divide by this particular quantity, which is arrow k. This will be equal to 1 over q. Finally, we want to make this q to stand alone, and for us to achieve this purpose, we are going to flip this expression. What do I mean by flip? Turning it upside down. That is the inverse or the reciprocal. If I turn this upside down, q will be the numerator, 1 will be the denominator. Same thing will happen on the right hand side because we want to make q to stand alone. And for us to achieve that, let's make use of this space for that simple expression. For us to achieve that, we are just simply going to take this q up and 1 under. So it becomes q over 1. And you know, of course, q over 1 is the same thing as q. So let's eliminate this 1, which is equal to same thing to the right hand side. We're going to flip this. So this becomes arrow k over p to the power of 3 over 2 plus ms. So this is the solution to this problem. You can see that q is standing all by itself, or we have expressed q in terms of the quantity we have at the right hand side. So that is the solution to that. So if you've written WAEC this year 2022 and you see something like this, I don't know if you can be able to recall what you've gotten as your answer, but this is the right solution to it. So the final problem is the expression for, that is the expression in physics for the period of a pendulum bulb. If you've come across that expression, then that is fine. So we want to make L, which is the length, the subject of the relation out of the parameters we're having. So we have T equals 2 pi square root of 2 pi multiplied by the square root of L over G. All right. The first approach is to divide both sides by this quantity, 2 pi, because this 2 pi is attached to this square root by multiplication. 2 is multiplying by pi, multiplying by the square root of all this quantity. So for us to remove this 2 pi first, so that we can be able to make or have access to this, for us to remove this 2 pi is just to do the opposite of multiplication, which is division. So I will divide both sides of the equation by 2 pi and do the same thing to whatever you do to the left hand side, you also do that to the right hand side. So that way this can easily cancel out, and I will be having t all over 2 pi equals the square root of L over G. Just as I told you that square can eliminate square root, you could easily just take the square of both sides of the equation, and whatever I'm doing on the right hand side, I'm doing to the left hand side. So this can easily cancel out with this, and what I'll be having here is L over G. After this would have cancelled, will be equal to what I have here is T over 2 pi all squared. Remember that you are to make this L the subject of the relation. So the last thing we are going to do is to cross multiply. And if you're taking this G across to this part, L will be left alone, and this will be equal to, you can position it at the front or here, the front or the back. So we have G into T all over 2 pi all squared. So this is the solution to the last problem we've just solved. So this is how simple change of subject formula could be. If there are problems you have on this and you're trying to change, you're not able to do that, drop it in the comment section. I'm going to work it out for you. Thank you very much for watching this video.